The ocean's heart is stopping, and it will kill North America. The map on the wall said normal. The sound in his headphones didn't. A low Atlantic hum he'd logged for years had shifted, like a heartbeat missing a beat, and then another. He circled the time code, glanced at the clock, and wrote one word in the margin. Warm? It wasn't a storm, it wasn't a submarine. It was a pattern hiding under waves and war. That quiet note would echo through grocery bills, blackouts, flooded basements, and migration maps. An ocean engine was stalling while most of us slept. To see how we got here, we need to rewind to the first quiet alarm. Roadmap. The plot. We're unraveling. We're going to follow a trail that was never meant to be a climate record. It starts with Cold War hydrophones, tuned for submarines, not currents, catching background tones that didn't belong. Those tapes led to math pulled from buoys and cables stretched from Florida to Morocco. Then the ice got louder. Greenland pouring fresh water into places where salt is supposed to make the heavy plunge. The sabotage wasn't a single blow. It was a drip, a lens, a lid. Along the way, strange bedfellows kept the receipts. Ship captains running the same North Atlantic lines felt their decks pitch against new chop and new fog. A retired Navy analyst, notebooks full of ocean heartbeats, watched the baseline drift. Grid operators in New England wrote playbooks for storms that parked for days instead of moving on. Coastal families redrew evacuation routes after one hurricane turned right, strengthened near shore, and didn't blink. Here's what we'll unravel. How military ears became climate eyes. How Argo floats, moorings, and algorithms stitched a nervous pulse. How Greenland's meltwater caps the engine. How the conveyor actually works, and when models and mud cores say it could tip. We'll step into weather chaos, hurricanes that curve differently, blizzards that bite harder, jet streams that stall, and then count the economic bruises. Insurance retreat, food shocks, shipping snarls. Open loops to watch for, a missing sensor in the Labrador Sea that leaves a blind spot in the most important room, an 8-degree winter shock that isn't a movie script, but a plausible local punch, and a surprise inside a hurricane tunnel experiment that changed how coastal mayors sleep. The first hint didn't come from a climate lab. It came from tech built to hear submarines, not oceans. And buried in those tapes was a question nobody wanted to answer yet. Had the Atlantic's engine started to cough? The first quiet alarm, Cold War ears, hear warm water. He never expected the ocean to talk back. In a windowless room, the analyst, call him Harris, spent nights listening for steel sliding through salt water. Hydrophones on the seafloor, linked by cables in a classified network, turned the Atlantic into a vast microphone. The background was supposed to be steady. Distant storms, the crackle of shrimp, the hiss of the sea. But in the late years of the Cold War, a subtle band in the hum began to drift. Stakes weren't abstract for him. A misread tone could mean a missed submarine. But the consequence he didn't see yet was bigger. Misreading the ocean could mean misreading climate risk for 2 continents. Harris logged anomalies anyway. A rise here, a seasonal shape bending there. He penciled tiny hearts next to segments that showed a repeating pulse. Winter loud, summer soft, winter loud, until the pattern wobbled outside the margins of his notebooks. What nobody in that room knew at the time. Those ears were brushing against an ocean circulation that breathes heat north and cold south. The AMOC doesn't hum like a machine, but its changes can slip into sound. Warmer surface layers shift how sound refracts. Fronts move, mixing changes. Harris only had a clue, not a conclusion. He walked his notes to a superior. The file stayed inside for years. Meanwhile, at sea level, the Navy's own oceanographers were wrestling with strange currents. Ships retransmitted temperature and salinity snippets. Pilots radioed unexpected turbulence near the Grand Banks. None of it proved a slowdown. All of it hinted the Atlantic was up to something. Action moved slowly in the open. In the 199s and early 200s, scientists fought for access to declassified hydrophone archives. They wanted to repurpose those time series, born for tracking submarines, into climate proxies. Walls came down in inches. Portions of SOSUS data remained locked. Others were released with gaps. But the pieces they got were enough to begin a different kind of analysis. Were background, sound speed profiles shifting in ways consistent with warming, freshening, and altered circulation? Harris retired with cardboard boxes of spiral notebooks. He kept one on his kitchen table, each page a grid of dates and amplitudes. He called them heartbeats, not to be poetic, but because they arrived with a rhythm he could feel after decades. When a journalist finally sat with him, he tapped a finger on the first wobble. "There," he said. "That's when it got weird. Here's the stakes moment. If those hydrophones had captured an early sign of a weakening northward heat engine, then governments had a lead time they didn't use. The consequences ripple through time. Earlier acknowledgement could have accelerated arrays, models, and municipal planning. Instead, the alarm was quiet, classified, and easy to ignore. Action widened when a few key datasets cracked open. Naval analysts partnered with civilian oceanographers to compare hydrophone-inferred trends with temperature and salinity measurements from research cruises and early floats. They weren't claiming a collapse. They were asking if multiple signals pointed in the same direction. The answer was cautious. Yes, the background environment was changing, and yes, some changes matched a fresher, more stratified North Atlantic. Impact landed in two ways. First, the ocean science community gained a bridge between military observation power and climate questions, opening a path to repurpose vast, expensive listening systems for planetary monitoring. Second, the whispers strengthened a hunch that would soon be measured directly. The overturning circulation was not the steady giant textbooks promised. There was a problem. The best places to catch the AMOC's downstroke, where surface water cools, grows salty and dense, and sinks, were also the hardest to instrument. High seas, ice, harsh seasons. Meanwhile, the classification stamp kept many SOSUS details out of reach, blurring the link between acoustic quirks and physical flows. Scientists begged for more access. Agencies hesitated. Years ticked by. While that was happening in New York, a grant proposal crossed a desk in Miami, a moored line across 26.5 degrees north, from Florida to Morocco, to watch the overturning continuously. The plan would become rapid, a necklace of sensors measuring temperature, salinity, pressure, and currents across the entire basin. It promised something the hydrophones never could, a direct view of the ocean's heartbeat. The first deployments in 2004 felt like opening a window in a sealed room. Data rolled in. The AMOC pulse dipped and surged with weather and seasons. There were surprises, big swings, a sharp downturn around 2009 to 201 that signaled a system far more volatile than the smooth reconstructions implied. That volatility didn't settle the trend debate, but it shifted the mood. If the ocean could lurch like that naturally, what would layered warming and freshening do? Meanwhile, USNAP, a northern sister, strung instruments across the subpolar Atlantic a decade later, tightening the net near Greenland and Labrador. The picture sharpened. Deep water formation, hot spots mattered, and freshening in those basins could gate the engine. Still, those early hydrophone whispers lingered like a faint echo under a louder beat, a reminder that we'd heard the first off notes long before we learned the song. In the aftermath, Harris made one more note. He wrote down a date from a rapid graph and drew a line to his old weird mark. Decades apart, different tools, same ocean. The files that finally cracked open had already been joined by a second line of evidence rising from the seafloor, an entire sensor web that would feed into algorithms designed to spot regime shifts in real time. The deep-sea AI watchers, Argo, Rapid, and a nervous algorithm. When the first Rapid figure started sketching a heartbeat, another voice was already whispering from the deep. Thousands of orange cylinders drifting up and down in 10-day breaths. They sank to 2,000 meters, slept, rose, and sent home slim columns of temperature and salinity. Argo floats didn't care about borders. Not stories, profiles. Enough of them, stitched together, became a moving atlas of the Atlantic's interior. Stakes were blunt. If this sensor web could see the circulation's mood swings, we'd gain time we didn't have. If it couldn't, we'd mistake weather noise for structural change and spend the next decade chasing ghosts. So scientists paired the always-on cables at 26.5 degrees north, Rapid's stethoscope across Florida to Morocco, with Argo's bloodstream map. Up north, USNAP tightened the mesh in the convective rooms near Greenland and Labrador. You could finally track pulses, not just averages. Here's where the experiment got audacious. A team in Germany trained a machine learning model on high-resolution ocean simulations, teaching it the language of geostrophy, how pressure gradients and Earth's spin shape currents. Then they fed the model years of Argo profiles and asked for something people said you couldn't get from scattered points: the strength of the Atlantic's overturning, including the deep southward return flow. The algorithm stumbled, overfit, relearned, and slowly drew a curve that rose and sagged like rapids measured line. Not a mirror, but a cousin. Close enough to imagine a future where a web of drifting robots, checked by a few hard moorings, tracks the ocean's pulse basin-wide. Meanwhile, in a fluorescent-lit lab, a grad student watched a different kind of heartbeat. She'd built a regime shift detector, early warning indicators that look for rising variance and slower recovery after disturbances. It drank rapid, OSNAP, and Argo-derived fields. One winter night, a bell icon blinked. Volatility uptick flagged in the subpolar density fields. Not collapse, not proof of trend, a step toward a more jittery rhythm. She didn't tweet. She emailed 3 supervisors and added a footnote. Confidence limited by winter gaps in the Labrador Sea. Action widened again. Deep Argo arrived, diving below 2,000 meters towards 6,000, finally sampling the abyss where much of the return limb creeps south. Biogeochemical Argo joined, measuring oxygen, nitrate, and pH, chemical fingerprints of mixing and ventilation. Gliders surfed along sharp fronts for weeks, mapping the edges where fresh caps and salty intrusions spar. Engineers tested fiber optic telecom cables as distributed sensors, reading tiny wiggles and backscattered light to infer temperature shifts and internal waves along the seafloor's highways. Even cargo ships pitched in, outfitting intake thermometers and salinity sensors along repeat lanes. The data torrent could mislead as easily as it could save. The 2009-201 sag at Rapid had spooked everyone. Then the line rebounded, a reminder that storms and winds can shove the system around for months at a time. So teams layered discipline over excitement. They constrained machine learning with physics, mass conservation, density relationships, potential vorticity. They ran data assimilation systems daily, pulling observations into models that respected ocean laws, and they kept 2 mantras on the wall: don't announce, cross-check. Patterns emerged, reconstruction still pointed to a weaker AMOC than mid-20th century baselines, roughly a 10 to 15% decline, with real uncertainty bars. Variability in the subpolar North Atlantic looked wider, especially in winters when fresh caps and wind patterns teamed up. Disturbances marched like waves through the system. A pulse of Greenland melt here, a North Atlantic oscillation switch there, sometimes aligning, sometimes canceling. Nothing screamed imminent crash. Everything suggested strain. Impact left the journals quickly. A U.S. East Coast utility subscribed to a seasonal bulletin that blended ocean state odds with jet stream behavior, planning gas storage and demand response around sharper cold shots in weak overturning winters. A fisheries council adjusted quota timing after salinity anomalies along spawning routes hinted at a moving nursery. An insurer trialed a coastal model that nudged surge risk higher during certain wind regimes when the larger circulation slacked, adding inches that matter stacked on a king tide. But the blind spot wouldn't let go. Winter in the Labrador Sea. Ice, darkness, and storms still ate instruments. OSNAP helped, but the caps breathing in peak season remained hard to watch. The algorithm learned humility, throwing too many alerts at first, then missing a few that independent checks later caught. The dance settled. Alert, audit, adjust. Field teams ran targeted process studies, microstructure profilers into near-freezing chop, drones sampling katabatic outflows, so the models learn thresholds as they exist, not as they look in clean simulations. After 2 decades, Rapid had enough length to speak softly about low-frequency change. The line didn't slope neatly. It sagged, shivered, and steadied at a lower mean than the earliest years. Media wanted a verdict. The teams gave posture. Weakening expected, variability strong, non-linear shifts can't be ruled out as freshwater forcing grows. Budgets followed. Deep Argo expanded. Moorings got longer lives. Ports and grid operators asked for tailored odds, not global slogans. City planners added a line to memos. Watch for AMOC-linked sea level bumps during specific wind states. Small on paper, big on a bad day. That's the pivot. We stopped waiting for perfect certainty from a fickle giant and started building an early warning system we could act on. And north of every sensor, blue rivers kept finding new cracks in the ice, feeding the one force the models agree will keep pressing: fresh water, where salt used to make the sea sink. Greenland's melt, freshwater as a saboteur. North of the sensor lines, the lid was lowering one summer at a time. Greenland wasn't just melting, it was reorganizing the Atlantic with buckets you couldn't see from shore. Blue rivers braided across the ice sheet, vanished into cracks, and roared to the bed. Hours later, that water hit fjords as a cold, light slick that refused to mix. It spread, thinned, and hugged the surface like plastic wrap. This is why the watchers lost sleep. The engine they were tracking runs on weight. Salt makes water heavy, cold makes it heavier. In the subpolar basins, the Labrador and Erminger Seas, the Nordic gateways, winter winds yank heat from the surface until it's dense enough to sink, pulling the Atlantic's escalator downward. Fresh water steals that weight. A lens forms. Storms claw at it and barely dent it. When the cold air screams off Greenland in January, the ocean shrugs and stays shallow. Fewer downstrokes, a weaker pull. Fishermen felt it before the figures did. In a small harbor on Greenland's west coast, nets came up light where they'd been heavy for years. Surface water tasted sweeter. The spring plankton bloom slid on the calendar. "It's wrong," a skipper muttered, squinting at a thermometer that used to be boring. Their logbooks matched satellite maps, a widening freshwater ribbon curling around Cape Farewell and seeding the Labrador Sea. Action moved offshore. Gliders traced those ribbons along the shelf break. Argo floats rode them until ice tried to chew them. Osnap's moorings felt density surfaces rise as the cap thickened. In some winters, storms beat it down and deep convection punched through. In others, the lid won. Mixing stopped shallow. A shipboard microstructure cast told the story in silence. 200 meters, 400, then a flat profile. No signatures of the deep overturn the engines needed. The sabotage wasn't a big bomb, it was grit and gears. Greenland sheds hundreds of billions of tons of ice each year. Add Arctic sea ice melt and rivers routing more fresh water through the Canadian archipelago and Fram Strait. And each summer adds another millimeter to the lens that matters most. One season doesn't break the escalator. 5 do. 10 set a new normal. The cap doesn't ask permission. It reconditions the next winter before it arrives. Feedback sharpened the edge. Slow the overturning, and a patch of the subpolar North Atlantic cools at the surface, even as the planet warms. That can slow melt from above. But warmer subsurface waters, still sneaking along boundary currents, gnaw at glacier fronts from below. Calvesing fronts retreat. Fjords open to storms that stir and freshen them more. Storm tracks themselves shift when that cold patch forms, steering lows differently across the basin. The lid influences the weather that protects or punishes the lid. There was a complication the teams repeated like a mantra. Freshening doesn't always mean shutoff. Winds can hammer the cap flat. Salty eddies can sneak in. The North Atlantic Oscillation flips the whole room's pressure map and decides whether winter favors or fights sinking. That's why process data mattered. It's also why the algorithms kept their caveats. Confidence limited by winter blind spots, thresholds local, not universal. Impact showed up where budgets lived. One weak convection winter lined up with colder European air and a few extra inches of sea level along the U.S. East Coast during nor'easters. A known pattern when alongshore currents relaxed with a weaker Atlantic push. Basements that never flooded took water twice in 5 years. Insurers didn't care about potential energy and density gradients. They raised deductibles. In models built to allow thresholds, adding realistic Greenland freshwater shifted the AMOC into a lower gear. Some runs stalled deep sinking under extreme forcing. Many fell to weaker modes that didn't bounce back on human timelines. Hysteresis, the stickiness that makes recovery harder than decline, loomed. Once you've built a layered, fresh surface, you need a bigger shove than the one that stopped sinking to restart it. The escalator doesn't idle gracefully, it floods. A micro moment on deck captured the psychology. A grad student, eyes red from a night watch, held a bottle from a near-freezing cast and checked salinity. The number blinked on the screen, lower than last year's by a sliver that mattered. She wrote it down without a speech. The ocean had made another small decision. Here's the truth the crews carried home. Greenland isn't a fuse that blows once. It's a steady hand on the throttle. Every summer, blue rivers find new cracks. Every autumn, the lens reforms. Every winter, storms test it. Some years, the cap thins and the engine catches. Others, the cough becomes a pause. The escalator still moves, but the steps scrape. And north of every mooring, the Saboteur keeps working. Quiet, relentless, and close to the rooms that decide whether the Atlantic sinks or skates. How the ocean heart works, the conveyor you can't see. To see the machine, start with a winter wind and follow the heat. Warm, salty water rides north near the surface, pushed west by trade winds, squeezed into a fast ribbon along Florida, then flung east and northeast as the Gulf Stream and the North Atlantic Current. That ribbon isn't a highway. It's a braided mess of meanders and eddies, each one stealing and returning heat like rolling suitcases changing hands in a crowded terminal. The motor underneath is weight. Salt adds weight. Cooling adds more. In the right rooms, the Labrador Sea, the Erminger Sea, the Nordic gateways, winter storms yank heat out so fast the sea looks like it's smoking. When the surface gets heavy enough, it stops being the surface. It sinks. That downstroke is the elevator into the deep limb, the cold, southbound river that balances the warm, northbound flow above. It's not a single chute. It's patches and plumes, leaning against submarine ridges, sliding through canyons, and braiding again thousands of kilometers later. Meanwhile, winds over the subtropics pile water against the western boundary. That pressure head sharpens the Gulf Stream along the coast, and Earth's spin keeps it glued there. Downstream, the current sheds eddies the size of small countries. Those eddies are heat couriers that run errands for the overturning, shuttling warm, salty water across the front into the subpolar interior, where storms can strip its heat and try to make it sink. In other words, the escalator steps are built by weather, then broken by weather, then rebuilt again. There's a second engine you don't feel standing on an Atlantic pier, the Southern Ocean's tug. Around Antarctica, fierce westerlies haul deep waters back toward the light. That upwelling helps close the global loop. Even if the North Atlantic falters, the South can keep part of the conveyor humming. That's why collapse isn't a single switch. You can weaken northern sinking, change pathways, and still have a global overturning beating faintly, while the local consequences near North America and Europe bite hard. The thresholds matter more than the averages. Add just enough fresh water at the surface in the sinking rooms, and you weaken the density contrast that powers the downstroke. The lid doesn't have to be thick, it just has to be stubborn. Winds may hammer it flat one winter, only for it to reform the next. Because the system has memory, last year's cap is this year's starting point. That's hysteresis in plain language. It's easier to stall a stratified ocean than to remix it once layered. Here's where the human stakes ride piggyback on physics. Northbound heat delivered by the top limb isn't a trivia fact. It props up milder European winters than latitude alone would allow. It steadies growing seasons by shaping storm tracks. It leans on the jet stream's route. In North America, the same circulation nudges coastal sea level. When the deep return slacks and the longshore currents ease, water piles a little higher against the coast. A few inches on paper becomes inches that matter on a king tide under an onshore wind. Inside the gears, you can feel the machine in small ways. A trawler in the Erminger Sea watches steam rise from near-freezing water under katabatic gusts. Below, a column tries to punch down and hits a fresher layer like a glass ceiling. A research mooring records a winter of shallow mixing and a spring bloom that slides on the calendar. A crew chief at a Delaware power plant gets a note. Weak overturning odds elevated this January. Stage an extra turbine for sharper cold shots. Complications don't rescue us, but they explain the stagger. Strong winds can open a hole in the lid and trigger sudden deep convection. A salty eddy can intrude and seed sinking where the cap looks solid. The North Atlantic oscillation can tilt the pressure field for a season, favoring either overturn or stalemate. The escalator doesn't glide, it lurches. But the baseline can still drift if freshening keeps adding friction to every step. So the heart you can't see is simple in principle. Heat north, cold south, powered by weight, and messy in practice. Cross small thresholds in the wrong rooms, and the downstroke fades from a steady elevator to an elevator that only works some winters. The top limb keeps delivering heat, just less reliably. The deep limb keeps returning cold, just more slowly. And along coasts built on assumptions baked into the old beat, the rhythm change shows up as tides that nip higher, storms that stall longer, and winters that bite in shorter but nastier bursts. The tipping point debate: models, proxies, and gut checks. To talk about tipping, we need three witnesses in the same room: models that run the physics forward, archives that remember the past, and people who've stared at this long enough to trust their instincts without overreaching. The stakes aren't academic. If the engine lurches, budgets snap, crops miss, and grids stumble. The question isn't if the AMOC changes, It's how fast is the next step, and will it stick? Start with the models that can resolve the real fights: fronts, eddies, and narrow pathways. High-resolution systems agree on direction, continued weakening through this century as the surface warms and freshens. They disagree on slope. Some sketch a gentle decline, others draw steeper steps when winters fail to mix. Most coupled Earth system models keep a dim heartbeat alive, even under heavy forcing, helped by Southern Ocean upwelling that refuses to quit. That means collapse rarely looks like lights out. It looks like a shift to a lower gear that lasts. Then bring in the toy boxes that aren't toys. Reduce complexity models where every lever is visible. You can watch salt advection feedback kick in. Weaken the overturning and you deliver less salt north, making it easier to weaken further. Add hysteresis and you get the dangerous shape. The path down is smoother than the path back up. Cross a density threshold in the sinking rooms, and recovery demands a stronger shove than the one that stopped it. Those frameworks don't give dates. They teach the traps. Now open the drawer of time. Proxies don't show us the AMOC directly. They show its fingerprints. In Greenland ice, abrupt changes in trapped air chemistry track wild swings in temperature. In North Atlantic mud, tiny shells record the water masses they lived in. Stack those hints, and you see episodes where the engine lurched. Heinrich events that flooded the basin with freshwater-laced ice debris. Dansgaard Esker jumps with decade-scale steps. And the younger Dryas, a cold relapse that arrived fast by geologic standards. The exact plumbing differed each time, but the moral repeats. Add freshwater in the wrong place, and the circulation can flip modes quickly. A paleoclimatologist once slid a finger along a Labrador margin core and stopped at a sharp band. 10-year step, she said. Not a prophecy. Context. The Earth can move fast. Our forcing is different. The engine sensitivities aren't. So why the fight in journals and headlines? Because the modern record is short and busy. Moorings give us 2 decades of exquisite detail, drenched in weather noise that can mask slow drift. Reconstructions that stitch together sea surface patterns and long-term variability suggest the AMOCs of today may be weaker than in centuries past, with a cold blob south of Greenland as one calling card. But other analyses that lean on air, sea heat flux relationships find more stability in the deeper limb than the surface might imply. Different filters, different emphases, same messy ocean. Meanwhile, early warning indicators, rising variance, slower recovery after shocks, have been applied to the North Atlantic skin. Some studies flag patterns consistent with approaching a critical transition. Others warn that applying those tools to short, non-stationary climate records can trip false alarms. Useful, but not verdicts. Here's the trap for mayors and ministers. Averages versus tails. Unlikely to collapse this century is not no problem. A small annual probability compounds over decades, and the damage curve isn't linear. A few inches of regional sea level rise during weak overturning states stack with tides and storm surge to cross thresholds in harbors. A nudge in jet anatomy lines up a blizzard over a grid that planned to the mean. Hurricanes find warmer nearshore corridors more often. You don't need a cinematic shutdown to get civic scale pain. Ask the people who live in this data. The careful voices land on seatbelt language. Weakening is already likely. Volatility looks broader. Nonlinear steps can't be ruled out as Greenland's freshwater keeps loading the dice. The cone of uncertainty narrows with each winter we actually measure in the Labrador and Erminger seas. But planning can't wait for perfect clarity. The asymmetry in cost sets the policy. Act on the high-confidence risks, insure against the tails. A modeler put it to me straight over a coffee gone cold. "I'm not in the business of dates," she said. "I'm in the business of odds." Her gut check wasn't drama, it was math. Shift the mean, widen the variance, and the extremes you meet in the real world show up more often and hit harder. So where does that leave us? With a timeline that's flexible, a physics box that explains the traps, a past that proves speed is possible, and a present that already hurts at the edges. With every summer pulse from Greenland, the threshold space around the sinking rooms tightens, with every added sensor and winter. Process study, the fog thins. The tipping point debate isn't a reason to pause. It's the reason to wire decisions to alarms, harden to the volatility we can see, and cut the drivers that keep pushing a stubborn system towards stickier states. Weather chaos. Hurricanes, blizzards, and the jet stream on Red Bull. If the AMOC is the ocean's pulse, weather is the face it makes when the heartbeat stumbles. Here's where it stops being theory. A weaker northbound heat delivery sharpens contrast in the wrong places and blurs them in others. That tugs the jet stream off its rails, slows storms that used to keep moving, and feeds the kind of extremes that turn errands into emergencies. Start in late summer on the southeast coast. The shelf is too warm, holding heat like a battery because spring didn't bleed it off. Hurricanes find that energy right where people live. When the large-scale steering currents soften, tracks bend closer to shore and forward speed drops. A storm that would have recurved now lingers, crawling along a warm ribbon. Rapid intensification doesn't wait for the open Atlantic. It happens a county away, at night, with sirens late and radar glowing red over neighborhoods that thought they had another day. A family in Jacksonville boards up like they always do. The forecast cone narrows. Overnight, the wind field doubles and pressure tanks as the storm slides a corridor that shouldn't exist. By dawn, shingles lift. By noon, stop signs bend flat. The surge isn't record-breaking. It's just a foot higher than anyone expected because regional sea level ran a few inches up during an onshore wind state tied to a weaker Atlantic push. That extra inch tips a basement from damp to ruined. Shift north as fall turns to winter. The jet starts acting like it forgot its route home. The temperature gradient that guides it has moved. Sometimes the jet buckles south, carving a deep trough that drags Arctic air into pipe-thin towns from Ohio to New Jersey. The cold shots aren't more frequent, they're sharper. Then, just as crews catch up, the pattern stalls in reverse. A moist plume parks for 36 hours over one interstate corridor. Heavy, wet snow snaps limbs. Snow-to-liquid ratios make plows useless. Roofs creak under weight they weren't built for. A grid operator in New England saw this coming at 3 a.m. Not from vibes, from a bulletin that stitched ocean state odds to jet behavior. They pre-staged crews along an ice corridor, spun up a battery fleet near hospitals, and shaved a day off the dark. The difference wasn't that lines didn't fall, it's that the lights returned faster because the playbook matched the ocean's nudge on the atmosphere. Now look west of Ireland. The subpolar cold blob sits like a pothole in a warming road. That sharp boundary acts like a speed bump for the jet, encouraging blocks that hang systems over one valley while starving another. In Europe, that means soggy, endless rain spells punctuated by out-of-season hard freezes. Vines bud early, then die back. Rivers rise, then drop, stranding barges. The same North Atlantic patch that cools the sea can heat politics when food prices jump and insurance deductibles climb. On the Gulf Coast and Mid-Atlantic, tropical remnants change character. Instead of sprinting inland and weakening, they slow and dump. Flood maps that were marginal become wrong. Inland towns watch downtowns go brown under stalled rain bands that reform over the same watershed hour after hour. The storm totals aren't cinematic, they're just long. That length closes bridges, then warehouses, then schools. Here's the paradox. People argue over at breakfast. The planet warms, but your street gets slammed by deeper cold. That isn't a contradiction, it's redistribution. A weaker AMOC reshapes where and when heat is delivered. With more moisture overhead, winter storms wring out heavier snow when profiles allow. Thunder snow over interstates that never knew it. Glaze ice on coastlines that barely saw it. Meanwhile, heat waves feel wetter because marine heat hangs in the air. Nights don't cool, ambulances run, human moments anchor the shift. A dispatcher outside Harrisburg watches a radar band refuse to move and reroutes 3 rigs, saving 2 from a pileup. A paramedic in Halifax chains the ambulance because lake effect bands shifted with a new wind angle. A Charleston mayor stares at a sunny day tide creeping over a curb and reads a line about AMOC-linked inches on certain wind states. None of them cares about acronyms. All of them need predictability. There's a feedback in the north that keeps forecasters up. Storms that slow can chew at the freshwater lid, mixing deeper in some winters and briefly helping convection. In others, persistent patterns spare the cap, letting it thicken and precondition the next season for shallow mixing. The atmosphere and ocean aren't independent. They step on each other's feet. So don't picture a single switch. Picture a year that starts with a hurricane, that strengthens near your driveway, rolls into a jet that can't pick a lane, and ends with a blizzard powered by an ocean that won't stop feeding moisture. The physics stays simple: density and wind, thresholds and memory. The consequences are tarps on roofs, grid crews and bucket trucks at 3 a.m., and grocery shelves light after too many minor storms in a row. Economic dominoes, food, energy, and supply chains. Follow the money to the waterline. In the Gulf of Maine and off Newfoundland, warmer skins stacked over fresher lids shove fish and lobster into new depths and latitudes. A captain who set 300 traps in a tight grid now burns diesel chasing an edge that won't sit still. 2-week shift in the molting window can turn last year's profit into this year's loan. It isn't a stock collapse, it's fuel bills, empty crates, and a bank manager who suddenly wants collateral. Stakes roll straight to dinner. If cod recruitment misses and mackerel dodge historic grounds, quotas cut fast. Processors idle. A cannery drops the night shift. The diner near the wharf cuts hours. In a Nova Scotia harbor, a skipper sells gear to cover a mortgage after 3 lean seasons and a storm that chewed the dock. He signs with hands that still smell like bait. Upstream, the plankton clock slips. Thin caps bring early blooms. Stubborn winters delay them. Larvae miss their meal and starve. Those gaps echo for years, then show up as lighter auction floors and a co-op that can't meet a covenant. It's not a headline, it's a hole in payroll. Farms far inland live inside the same wobble. Storm tracks nudge, soak the wrong week, and then stall. In the U.S. Northeast and parts of Europe, spring starts early, frost size blossoms, and tree fruit writes off a year. Insurers pay once, maybe twice, then change the rules. Corn and soy calendars slide to dodge saturated fields under stuck rain bands. A soy buyer who counted on barges watches a high water closure ripple through contracts as 3 storms stack over the basin and keep locks shut. Energy takes the hit as bill and blame. A sharper January snap pushes heating demand beyond plans tuned to averages. Storage misses the tail. Spot gas prices spike for a week. Utilities spin peakers, drain reserves, and mail the pain a month later. Summer brings marine heat waves that load the air with humidity, raising nighttime demand just when a stalled thunderstorm drops inches on a substation built on a 100-year line. That's now a joke. The lights don't just go out, they come back slower when crews thread wash roads. Ports turn into coin flips. A tropical system that would have curved away slows and crawls. Berths close. Cranes sit. A port up the coast steals the call, but runs its own channels higher than usual because regional sea level pops a few inches. During onshore wind states linked to weak overturning, pilot windows shrink, drafts get cut, ships leave boxes. Those boxes are missing parts 2 states away. Assembly lines wait on a tide. A trucking dispatcher feels the chaos minute by minute. Back-to-back weather pauses force reroutes around an Appalachian corridor that didn't used to flood. Hours of service rules laugh at the schedule. She buys spot capacity at eye-watering rates to keep a cold chain alive, while the only passable bridge adds 90 miles. The shipper pays, then moves next year's distribution center inland. Inflation doesn't climb like a ramp, it jumps like footsteps. A fishery misses, a frost wipes fruit, a flood takes grain, and a port delay spikes freight. Grocery buyers hedge and shelf tags update weekly. A school district renegotiates bread and milk because the warehouse flooded twice in 4 years and insurance walked. A state relief fund designed for single disasters covers a run of minor ones that together cost more. Insurance pulls the quiet lever. After coastal wind losses and inland flood repeats, carriers raise deductibles, cap payouts, or leave zip codes. Mortgage lenders read the retreat and require flood escrows. Force-placed policies land with payment shock. Values bend. Tax bases wobble. A mayor with a waterfront plan hears from bond counsel. Higher interest, shorter maturities, and a question she can't answer about circulation-linked sea level bumps on bad wind days. Adaptation bills arrive with fine print. Heat pumps cut winter gas risk, but need rebates that live and die by politics. Batteries shave peaks if you can. Finance them. Elevating switchgear pushes the risk line, but the money competes with schools and roads. Offshore wind makes sense in a hotter world. Then a run of intense nearshore storms forces new maintenance cycles and pricier insurance for turbines. Supply chains relearn the map. Railroads sell weather hedges that price in persistent rain delays. Agribusiness moves silos west of the floodline and buys barges that can ride higher flows. Some ports pour concrete into taller wharves, add breakwaters, and anchor cranes for bigger winds. Others accept geography and trade volume for reliability and cargo that tolerates delay. Insurers and reinsurers model wider tails. The premium lands, like always, in rent and bread. There's one resilience dividend worth the ink. A port authority subscribed to sub-seasonal bulletins that tie weak overturning odds to coastal water levels. They advanced stacks, shifted shifts, and slid one oversized call. A minor storm plus a king tide plus 2 extra inches lapped a line that would have flooded. Nothing made the news. That's money saved. It all sounds abstract until you count receipts. A roof you re-roofed twice in 5 years. A deductible that doubles. A week of overtime you worked to make up a food bill you didn't plan. The AMOC's wobble doesn't send an invoice. It nudges every price you meet between the dock and your door. Your life in a Weak-AMOC world, a year and fast forward. January bites harder than the forecast app. The thermostat clicks higher, the gas bill lands like a shoulder check, and a push alert asks you to cut use between 6 and 9. You boil water for a neighbor with frozen pipes and learn which cupboard holds the space heater. Your kid's school delays buses, you pack gloves into a backpack that used to carry soccer cleats. You meant to build an emergency kit. For now, it's a shoebox with meds, a flashlight, and a list of phone numbers you haven't checked in years. A storm parks for 36 hours, drops heavy snow, and pinches power lines. February tries to thaw and then refuses. You cycle the fridge on and off because the outage dances back every hour. The sump pump barely wins. You finally find the breaker. The generator you trusted drinks fuel faster and cold. Across the street, a neighbor's solar and battery run a fridge and a space heater all night. You ask what they paid and write down the model. March forgets what it's for. Mornings start in a parka, afternoons in shirt sleeves. Your tomatoes sulk under a grow light because last spring arrived in February and this one didn't. Allergies sprint ahead 2 weeks. Your doctor nudges you to refill early. On Sunday, you drive to your parents' ranch by the river and find the access road under brown water from a rain band that wouldn't move. April adds anxiety to bills. Insurance renews 18% higher with a rider that carves out basement contents. Your agent mentions regional sea level anomalies on certain wind days. You hear static and buy pallets for boxes. A microburst rips shingles. The roofer says 3 towns got hit by the same stalled line and books you for next week. You move photos upstairs and promise yourself a cloud backup. May behaves until it doesn't. A 3-day heat wave lands on air still holding spring's moisture. The utility texts peak event. You delay the dryer and cook on 1 burner. The house stays sticky. The window unit taps out at 4 p.m. A refinery 2 states away goes offline after floodwater cut their access road, and gas prices jump. The grocery looks normal, the total doesn't. June is decisions. Your boss rolls out a severe weather flex policy after 2 school closures in a month. You buy a second 5-gallon jug, a hand pump filter, and 2 weeks of meds that can't be interrupted. The block floats a shared battery with a rebate and a contractor who knows critical loads. You add a thermos and a flashlight to the trunk and call your parents about a simple plan. Who calls, where keys are, 1 hotel inland that takes pets. July brings fireworks and flood maps. The news shows new lines. Your house isn't red, 2 blocks away are. A neighbor's policy isn't renewed, another's deductible doubles. You walk the dog at high tide and count puddles along a curb that used to stay dry. You wonder if you should move in 5 years or wait and hope rates fall. August looks like a postcard and behaves like a trap. A tropical storm shoulders up the coast, slows and rains over land one day longer than expected. You pull the car up the hill and help a neighbor swap a cracked sump hose. You don't flood. 2 streets over, they do. The city opens a cooling center and keeps it open after the storm because the dew point won't drop. September tries a hurricane. The track bends late, winds don't. You pack the meds box, water, chargers, and a cheap battery. You stay. Your friend leaves. 2 days later, you drive her home to a roof stitched in blue tarp and learn which lot stayed dry. October can't pick a lane. 1 week feels like August, the next like January. The heat pump you installed with a rebate handles both. Your bill slides. A landlord friend raises an electrical panel. It looks silly until the next sideways rain stops a foot short. November turns into a checklist. You label 2 bins, rotate water, buy shelf-stable meals that don't need heat, and teach the kids to crank radio. You pick 1 warm room and door snakes. You print contacts and stash them with spare glasses. The block chat tests an alert, pump test Saturday, battery Sunday. December misses with the storm and hits with the cold. You host family under LED lights and talk about moving lines. Farther from the coast, higher from the creek, closer to a substation, closer to a hospital. You don't solve everything. You made a dent. The group chat becomes an early warning system you trust more than an app, and you end the year with a new habit, living by the ocean's calendar, not the weatherman's tone. The blind spots: politics, media, and the comfort of later. If the last year made risk feel like receipts, the next hurdle is quieter and meaner: later. Politics runs on quarters and news cycles. The AMOC doesn't. It loads budgets in the background and shows up all at once when a stalled storm won't leave or a high tide climbs a curb that never used to get wet. Here's how later wins. A council hears "unlikely to collapse this century" and translates it into "we're fine." The qualifiers, weakening, fatter tails, local sea level bumps, fall off the memo. A state house sees the price tag for raising a substation and punts it to next session. Then a nor'easter parks for 2 tides, basements fill, and the same substation trips. The money goes out anyway, just to drywall, pumps, and overtime, not to the fix that would have kept the lights on. Media swings don't help. A blockbuster taught people to see the AMOC as an instant ice wall switch. Scientists correct the myth, and the correction gets heard as comfort. Headlines whiplash between imminent collapse and nothing to see. Audiences turn numb. If you're a mayor trying to sell a bond, that noise is a sedative you can't afford. Funding moves like a tide at the wrong moon. Arrays in deep Argo need boring annual money. Grants arrive as bursts and leave gaps. A national budget trims a science line to fund a tax cut. A winter mooring skips a service. A sensor dies in the Labrador Sea in January. Every model downstream widens its error bars, and confidence slides in ways nobody sees on TV, but every operator feels. Misinformation slips through those cracks. One column says AMOC hasn't changed in 60 years, cherry-picking a single method and ignoring mooring volatility and proxy context. A viral thread declares a collapse next summer off a statistical warning meant to flag risk, not a date. Both sell certainty. Neither pays the bill when a utility misplans storage or an insurer misprices flood. Meanwhile, good intentions carry the wrong message. "We should wait for better data" sounds prudent until you realize better data arrives because you funded it, and every delay makes cheap moves expensive. Elevating switchgear, wiring critical loads, restoring wetlands, and adding batteries to shelters pay back in ordinary storms and heat waves, not just in AMOC-linked bumps. A grid hardened for ice rides heat better. A wetland restored for surge filters water every day. People also have finite panic. After fires, pandemics, and bills, asking them to care about a circulation index feels like asking them to love a spreadsheet. The antidote isn't louder doom. It's precision tied to action. Tell a coastal neighborhood. On certain winter wind states, under weak overturning odds, expect 2 to 4 extra inches on high tides during storms. Move cars above this line. Tell a school board. Budget 1 to 2 additional closure days a year for stalled snow or flood bans. Tell a hospital. Wire 1 wing to run on batteries for 12 hours and drill twice a year. A newsroom micro-story says it cleanly. An editor pitches Gulf Stream collapse imminent. Another pitches nothing to see. The climate reporter lands in the middle. Atlantic engine weakens. Local risks rising. Fewer clicks than panic, more than complacency. A week later, a mayor calls asking for that exact piece for a bond meeting. "We're writing triggers. We can't sell apocalypse. We can sell readiness." That's the pivot. Politics that banks wins on. Avoided outages, not ribbon cuttings. Media that carries uncertainty without smothering urgency. Citizens who trade vague worry for short lists and neighbor chats. Publish triggers and thresholds. Drill them. Tie alerts to actions and translate odds into inches, hours, and crews. When alarms fizzle, explain why. When they hit, count what was saved. Later multiplies harm. Now multiplies trust. And trust is the only currency that spends when the ocean's beat stutters and someone has to flip a switch before the headline forms. The levers, what bends the trajectory. We can bend this, not by shouting at the ocean, but by turning the few knobs that shift risk fastest. Start with what loads the dice, heat and fresh water. Cut both and you ease pressure on the engine. Some moves buy time in years, not generations, and years matter when budgets and neighborhoods live month to month. Methane is the sprint. It hangs for roughly a decade, and trimming it cools the near-term path. Plug leaks from oil and gas fields with continuous monitoring, verified repair deadlines, and penalties that actually bite. Capture landfill gas, tighten venting at wells, pay farmers to cover lagoons, and upgrade digesters. Black carbon is the week-to-week lever. Filters on diesel buses and port equipment, cleaner shipping fuel near ice and snow. Less soot means brighter spring snow, slower melt, and fewer millimeters added to the freshwater lid in the rooms that decide whether the ocean sinks or skates. Carbon is the marathon. Grids that lean hard into wind, solar, and firm, low carbon cut the background heating that keeps nudging thresholds. Heat pumps trade combustion for efficient electricity and soften winter gas spikes that now arrive in sharper bursts. Seal and insulate buildings so homes ride through cold snaps and heat waves with fewer peaks. Spread storage where it buys the most. Neighborhood batteries, school microgrids, vehicle-to-home inverters that keep fridges and furnaces alive for the hours that matter. Protecting salinity isn't a phrase in city slogans, but it should be. After big storms, rivers can dump pulses that stratify estuaries and shelves. Reconnected floodplains and upstream sponge basins spread those pulses out. Wetlands on the edge slow and filter freshets before they harden the lid. None of this fixes the AMOC. It trims the local stratification that trains storms to stall and tides to climb higher on bad wind days. Think of it as taking gum off the escalator steps. There's a navigation lever we rarely name. Stay out of the engine room. Arctic shipping that hugs sea ice margins in melt season sprays soot where albedo counts most. Resource projects that perturb freshwater pathways near Greenland and the Labrador Ranger. Edges add risk where thresholds live. Draw red zones for operations during melt season, require best available fuel and coatings, and incentivize routes that keep distance from sea ice edges when the sun is high. Information only matters if it moves hands. Upgrade forecasts that translate ocean state odds into decisions. If weak overturning plus onshore winds add 2 to 4 inches to regional sea level this weekend, a harbor master needs one line and a time. Close low lots, move stacks, advance departures 6 hours. If subpolar SST patterns signal higher, jet block odds, grid operators get a cold snap alert 3 to 10 days out with pre-stage coordinates for crews and batteries. Barge lines want stall probabilities on river corridors. School districts want closure odds pegged to rain band persistence. Hardening is not a press conference, it's a list with sockets and screws. Elevate substations and switch gear above revised flood lines that include circulation-linked bumps. Bury or laminate spans along ice-prone corridors. Install sectionalizing switches so crews can isolate damage and restore faster. Require hospitals, water plants, and data centers to wire critical loads panels for batteries and generators, sized for at least 12 hours of islanding. Set fuel storage rules for 72-hour stalls, plus a resupply delay. Managed retreat is the hardest lever because it touches memory and equity. Start where harm repeats. Voluntary buyouts at fair prices for homes that flood again and again. Bank the lots as green buffers, not future tax-based fantasies. Where staying is the choice, raise standards. Elevation, wind, and floodproofing that match what's actually coming. Pair risk-based insurance with subsidies so low-income families aren't pushed into the floodplain by premiums. Equity is the only way these levers hold. Target soot filters to depots and ports next to apartments. Extend heat pump rebates to renters with landlord requirements. Fund community solar plus storage at clinics, shelters, and multifamily buildings, so backup isn't a luxury. Train local crews to install heat pumps, wire batteries, raise panels, maintain pumps, and service sensors, keeping paychecks in the neighborhoods that take the weather. Science is a lever with quick payback. Keep rapid humming, expand deep Argo, and hang distributed sensing on seafloor fiber. Fund winter process cruises in the Labrador and Erminger Seas on a schedule, not as a favor. Make data open by default with protected lanes for sensitive feeds. Build dashboards that display odds with plain language actions and confidence bars. Policy turns ideas into muscle memory. Set methane performance standards that ratchet automatically. Tie port grants to soot cuts and resilience upgrades. Condition federal insurance backstops on adopting updated flood maps that include AMOC-linked sea level patterns and using buyouts over rebuilds in repetitive loss zones. Create resilience tranches in bonds with lower coupons for projects wired to early warning triggers and audited drills. A micro story shows what success looks like. A coastal hospital watches a heat plus stall index tick red at noon, pre-stages staff, and islanded one wing on batteries overnight. The ER stayed open. The ICU never flickered. The after-action note was boring on purpose. Zero transfers, no ventilator alarms. Not drama, continuity. None of this waits on a collapse date. We already see wider swings, fatter tails, and inches that matter. Every avoided ton of methane, every soot filter near snow, every elevated panel, every battery at a shelter buys slack in a system with memory. We're not passengers, we're mechanics, cooling the bearings, lightening the load, and installing gauges tied to switches. Someone will actually flip when the ocean beat stutters. Watching the heartbeat, the next-gen sensor web. Data that doesn't move hands is trivia. So the push now is simple. Turn the Atlantic from a patchwork of measurements into a living, vital sign you can plan around. Fast enough for ports, precise enough for grids, clear enough for mayors. Start with the backbone we trust. The rapid line at 26.5 degrees north has become routine. Service cruises, moorings scrubbed, batteries swapped, instruments calibrated. 2 decades of continuity is its superpower. North, OSNAP, stitched a mesh across the convective rooms near Greenland and Labrador. South, SAMOX tightened the flank. Fixed anchors frame the problem. But the ocean moves. You need mobility. Deep Argo is the quiet revolution. Standard floats gave us the top 2,000 meters. Deep Argo dives to 6,000, sampling the abyss where much of the AMOC's return limb creeps south. Put a few hundred Deep Argo floats in the subpolar and subtropical basins, and guesswork shrinks. Layer biogeochemical Argo on top, oxygen, nitrate, pH, and you get timestamps on when water last breathed at the surface. Physics and chemistry together make the picture stick. Gliders do the stubborn work. They sip power, ride density surfaces, and map the razor edges where fresh lids meet salty intrusions. The thresholds that decide whether winter mixing wins or loses. Park a picket line of gliders along the Labrador and Erminger edges each winter, and you finally watch the cap wax and wane in the weeks that set the season. Pair those transects with shipboard microstructure bursts during gales, and the algorithms learn how real thresholds look. Messy, jumpy, local. Then there's the hack that scales. Fiber optic seafloor cables already span the Atlantic carrying the internet. With distributed acoustic and temperature sensing, tiny changes in backscattered light turn those cables into thousands of virtual thermometers. You won't get salinity, but you'll see temperature gradients and internal waves along routes we could never afford to instrument. Anchor that with smart buoys on key sections that log conductivity, temperature, and pressure, and geometry turns into flow. Commercial hulls can carry this too. Cargo ships cross the same lanes daily. Give them standardized intake sensors, GPS stamps, and simple calibration kits, and you convert a fleet into moving samplers. Fishing vessels can host temporary packages along migratory corridors, following water masses where science ships rarely linger. Overhead, small satellites watch the skin, sea surface temperature, color for blooms, altimetry for sea level. The ocean's face hints at its muscle. The interior closes the case. Hardware without software is noise, so the next-gen brain bakes physics into machine learning. Models respect conservation of mass and potential vorticity. They don't hallucinate overturning where density won't allow it. Daily data assimilation pulls everything into nowcasts and short forecasts. A harbor master or grid operator can use. Early warning modules watch the right variables. Density in sinking rooms, winter mixing depth proxies, sea level patterns along the southeast US for rising variance and slowing recovery, translating them into odds with confidence bars. Here's what a good week looks like when the pipes connect. On Monday, a subseasonal bulletin flags elevated weak overturning odds plus an onshore wind setup likely to add 2 to 4 inches to regional sea level next weekend. A port advances departure windows, shifts high stacks off the lowest wharf, and moves cars from flood-prone lots. On Wednesday, a grid operator reads a jet block probability tied to subpolar SSTs and pre-stages crews along an ice corridor, while a hospital toggles a drill that islands one wing for 12 hours on batteries. Saturday's king tide and a modest storm arrive. Water laps a line it would have crossed. Lights flicker, then hold. Nothing makes the news. Success is quiet. Obstacles are dull and deadly. Bureaucracy can choke data sharing. Cybersecurity is non-negotiable when your sensors hang on the internet's backbone. Winter maintenance eats budgets and people. The fix is governance baked into design. Make open standards the default, with protected lanes for sensitive feeds. require live quality flags and machine-readable metadata so bad sensors don't poison good models. Fund maintenance as operations, not as grants that end on a fiscal calendar. Train a cadre, techs who can swap a CTD in a gale, and data engineers who keep pipelines alive at 2 a.m. equity. Belongs at the dashboard, not in the appendix. Coastal communities that live the risk get first, clearest interfaces. A small city shouldn't need a PhD to read a tide alert that adds AMOC-driven inches. A clinic shouldn't need a consultant to link a stall probability to a generator test. Translate odds into inches, hours, and crews, and push them where decisions get made. This is the turn. From watching the ocean like a mystery to monitoring it like a patient. Build the monitors. Wire the alarms to checklists. Keep the chart open where the people who move money and crews can see it. When the bell rings, someone pulls the lever. Governance in a whiplash climate, playbooks, not press conferences. Alarms are useless without authority tied to a checklist. In a whiplash climate, governance isn't speeches. It's pre-agreed triggers that move crews, cash, and cargo before the headline forms. The playbook lives on one laminated page with names, thresholds, timers, and a line that says who pulls which lever when the bell rings. Start with triggers wired to the sensor web you're already funding. If the sub-seasonal bulletin flags weak overturning odds plus an onshore wind setup expected to add 2 to 4 inches to regional sea level, coastal cities flip to elevate posture by rule. Close, low-lying garages, move municipal fleets to high lots, test pumps, pause elective dock work. No podium, no vote. Just a duty officer, a timestamp, and a checklist. Money moves by rule, not request. A resilience fund keyed to a storm stall index releases preset amounts to school districts for portable power and to utilities for overtime when multi-day rain bans look likely. Heating fuel price caps snap on during sharp cold shots verified by ocean jet indicators, paired with guaranteed state procurement, so retailers aren't punished for staying open. Caps sunset automatically after 7 days. Interstate compact smooth seams that usually snag. Grid operators agree on a shared definition for cold snap plus high demand, with mutual aid paperwork, liability, and crew staging baked in. Ports coordinate surge windows, staggering bursts when weak overturning plus wind states threaten higher water. Barge corridors shift to night runs on a 5-day outlook, and lockmasters get authority to hold or flush based on a river stall metric, not a governor's press call. Supply chains need their own tabs. Customs adopts contingency clearance during 24-hour water-on-wharf alerts, so known cargo can move under bond. Railroads pre-authorize crew pool shifts and hours of service waivers tied to declared stall events. Distribution centers switch to flood footing, with floor stacks raised and reefers staged on higher pads when the coastal odds cross a line. Trust arrives by drill, not draft. Twice a year, cities run AMOC bump exercises. Pump tests, shelter microgrids, hospital islanding for 12 hours, harbor drafts recalculated with the extra inches. After-action notes feed thresholds. If a trigger jumped early, tighten it. If recovery lagged, lower it. Science updates version control into policy. Nobody staples PDFs to binders. Nobody opens. Equity stays on page 1. Relief and pre-staging go first to repetitive loss neighborhoods that lack private buffers. Portable batteries for medical devices, motel vouchers tied to thresholds, transit that includes dialysis schedules and service animals. Alerts land in the languages people speak, not just the one on the state seal. Pay community liaisons and give them seats in the ops room. Data governance underwrites all of it. Agencies sign MOUs that make sensor feeds open by default, with protected lanes for sensitive infrastructure. Dashboards publish odds with confidence bars and plain actions. High tide 2 to 4 inches above normal Saturday afternoon. Move cars above this line by 1 p.m. Alerts without paired actions stay quiet. Legitimacy lives and dies on error management. False alarms erode compliance. Missed alarms erode lives and budgets. Publish targets for both. When an alarm fizzles, explain why and what changed in the thresholds. When it hits, count what you bought. Outages avoided, hours saved, dollars not spent. A micro story shows the muscle. A regional grid operator watches a dashboard that blends jet block odds with AMOC-linked sea level patterns. The index crosses red at 11 a.m. By noon, trucks roll toward known ice corridors, a battery fleet preloads near hospitals, and hospitals island one wing by 6 p.m. The cold arrives. Transformers still blow, but restoration cascades faster because switches were staged and crews were parked. An elderly care home never flips to dark. Policy should reward readiness, not rhetoric. Typort grants the drills and measurable soot cuts. Condition federal insurance backstops on updated flood maps that include circulation-linked sea level patterns, and on using buyouts over rebuilds in repetitive loss zones. Offer lower bond coupons for projects wired to early warning triggers with audited exercises. A mayor told me, "I don't need certainty, I need cover." Playbooks give cover to spend money, move people, and mildly inconvenience a city for a day so it isn't homeless for a month. When the ocean's beat stutters, hands move without waiting for a press conference. That's governance built for a climate that stalls, surges, and tests every delay. Timelines and truth. What we know, what we don't. Here's the clock without the comforting filter. Decadal risk isn't zero. By mid-century, it's higher. Most comprehensive models keep pointing the same way. Weakening through this century, helped along by surface warming and freshwater input. They don't draw the same slope. Some show a slow slide, others add steps when winters fail to mix. Southern Ocean upwelling likely keeps a dull global heartbeat alive, even under heavy forcing. So off rarely means off. It means a lower gear that lasts long enough to matter for budgets and lives. Think in scenarios, not a single date. One path is stepwise. A few years of softer winters and stalled storms, then partial rebounds when winds tear a hole in the cap. Another is a regime shift. The engine drops to a weaker mode and sits there for decades. A full shutdown remains contested and probably rarer than the scariest headlines. But the tail isn't empty. Planning lives inside that asymmetry. Modest odds, big costs, uneven impacts. What compresses or stretches time? Greenland's summer pulses that thicken the lens. Arctic freshwater storage that flushes into the Labrador Sea. Soot on spring snow that darkens ice and speeds melt. The state of the subpolar gyre, which decides where salt lines up to fight the lid. And the business cycle of sensors. Each winter cruise tightened. Each deep Argo profile added narrows the fog. Each budget gap widens it. Risk clusters. A run of fresh summers plus cap-friendly winters can stack a weaker decade. Households need a 5D CNNers and 20-year frame. 5 years. Expect wider swings. Stalled systems, a few extra inches of coastal water on certain wind states, and nastier cold snaps. 10 years. Build in volatility. Insurance that climbs in steps, energy bills with spikes, and home upgrades that pay in any weather. Heat pumps, raised panels, backup for critical loads. 20 years. If a weaker mode sticks, migration grows away from repetitive loss zones, and neighborhoods that hardened early hold value better. Cities and utilities should stage work. Phase 1, clear maintenance debt, raise known weak points, wire critical load panels, and connect operations to ocean state dashboards. Phase 2, expand distributed storage, add water and comms redundancy, and lock in procurement rules for stall events. Phase 3, redraw land use maps that include circulation-linked sea level patterns and shift capital toward higher ground corridors and microgrid anchors. Update thresholds yearly as the sensor web sharpens odds. Let's close the loops. The Labrador Sea blind spot is on the to-fix list. Winter process moorings, deep Argo density curtains, fiber optic lines reading internal waves, and a glider picket to watch the lid breathe. The 8-degree winter shock lives as a paleoclimate scale. Proof that rapid regional cooling is physically possible under heavy freshening, even as the world warms, not a forecast for your street. The hurricane tunnel surprise, warm nearshore corridors that allow late intensification, is already showing up some years. And port and grid playbooks now treat that as a slow, closed danger, not an offshore one. What we don't know still matters. We don't have century-long direct measurements. Proxies carry their own slop. We can't name how often the cap will win in the next 2 decades. We can't put a clean percentage on a regime shift by 205, but we know enough to move without theatrics. The AMOC is likely weakening, volatility is wider, coastal water levels, storm behavior, and winter snaps respond, and early warning tied to hardening saves money and lives. A family's micro-decision keeps it honest. 1 zip code inland, raised panels, a heat pump, and a modest battery, a block chat tied to city alerts. 2 years later, a stalled storm closed their old route. Their lights stayed on, meds stayed cold, the car had range, and they had a bed for a neighbor. That's timelines translated into Tuesday. The meaning and the move. The ocean's heart is weakening, The next beat depends on how fast we cut drivers and wire alarms to action. If you want the coastal retreat and grid hardening playbooks we use with mayors, watch the next episode. Subscribe for the sensor web rollout and drop your city in the comments so we can tailor the triggers you'll actually use.